April 10th, 2016. As we had a strong quake this morning, it was about 5:28 a.m. on the East Coast, 10:28 local time there in the Himalayas. It was in Afghanistan, but it shook the capital of both Afghanistan, Pakistan, and India. We'll pull this up. Now, you've got the Indian plate here on the bottom, that big shark tooth where India is, and it pushes under the Himalayan mountains. Now, the Eurasian plate at the top is pushing also under the mountains, and they collide there, pushing the Himalaya straight up. So you have that pincer movement. That's what we're dealing with. But what is causing the pressure on the plates? We're going to get to that. Now, in Afghanistan, they're saying there were strong tremors felt in India and the Pakistan capitals also. But remember, we're dealing with Afghanistan, very wide felt quake because it was so deep. But they're saying in this area called Shatrail was the epicenter. There was landslides reported, things like that. But again, buildings and cities away from this thing were collapsing. It said 4 people were killed at least, and this was just in Peshawar, and many others injured in Pakistan as the earthquake hit South Asia on Sunday morning. You can see the shake area in the right. It says the earthquake hit parts of Punjab and Paktikwa near the Afghan border, shaking buildings in the Afghan and Pakistan capitals. It was according to the USGS. Now, again, the epicenter was not heavily populated, but last year in October, I think it was, they had a quake there and people were killed in an avalanche, and I think that's what has happened today. But you go back to about the 6th, and I don't know if it's a coincidence or not, with between the earthquakes increasing and the solar flares increasing, coronal mass ejections, all the filaments rising. But that's about how long CERN's been running full power. We're also watching that large sunspot. But you can see that it started in Vanuatu with 2 quakes, one day, one the very next day. One was on the 6th, one was on the 7th, both strong 6s. Now, since I got this information up, I checked back, guys, and that pressure has moved around the ring of fire to the very top off the Aleutian Islands. And we'll take a look at it. They're saying it's a 5.4, it's 92 kilometers west-southwest of Mackinac Island, Alaska, 47 kilometers. But the big quake this morning, guys, was 210 kilometers. It was deep. Now, shallow earthquakes do a lot of damage locally, but this deep quake shook a large area. At that time, there was a sudden burst of energy from the sun that was caught on the ACE satellites coming in just after 10 UTC time. Now, during that hour, there were about 3 bursts. It was picked up with the radio solar wind speed here. The temperature rose, the speed rose, and the density rose, and I think that was key in the very top. And all of this started happening just after 8. Now, it takes 8.2 minutes for a burst of energy from the sun as far as this type of burst, as we look at it from the back side on stereo ahead. That's why it's on the other side. But notice at about 7:39 UTC time, we see the pulse is coming off. But in 8.2 minutes, a flash of energy like a solar flare can reach our planet, which is over 92 million miles away. Let's look at some SDO images, and if you pay attention, these are all Earth-facing. The large sunspot has come around, but as we've seen in the past, it reaches out with large magnetic tentacles. Any area it touches, small filaments, it energizes and blows them off the surface. And that's what's happening with the sunspot, and it's growing larger. It still has a beta component, but watch this particular filament right there. You're going to see energy move from the large sunspot through these tentacles, touch that area, and it's going to explode. You'll see the filament release. The tip will explode as it comes out in a whip-like motion. It will be geoaffective. It will affect our Earth, not directly, but as it expands out, we will see an impact. Again, the scale of the Earth, it's smaller than just the sunspot. Look at that explosion. But remember, the Earth is on this side of the sun. I moved it from the side for reference to the center, and that's very close to our location. We're just below the equator of the sun in the sun's actual southern hemisphere. Here you'll get a good idea of the velocity and the amount of density that was thrown out by this reaction. Again, The sunspot's going to react. It's going to reach over, send a wave of energy into the filament. That will be more than that filament can take. It will explode from the surface. You'll see the points of explosion, and then what happens, look at the very base where it left from. You see that widening area, guys, there where it gets lighter. That's when that magnetic energy that is not thrown off the sun is pulled back into the sun by the gravity, strikes the surface, and causes what's called a secondary flare, called a Hyder flare. You can look it up, Hyder. That flare in itself will emit an energetic burst. So we've seen a series. Now, this is the sunspot. It's by far the largest we've seen in quite a while. The blue area to the left, if it continues to develop, we're going to have a double magnetic component in this particular sunspot. Again, it's beta. It could go alpha, beta, and then gamma. But that's what we're dealing with, and that is strengthening. Now, watch the magnetopause. CERN is not pulling it down. Even though it's running at high power, they're running very few collisions with very few particles, and we've seen that before. They're going to ramp all of that up into the summer, into the fall, up into November. But notice on the magnetopause, after 8 o'clock, 8 a.m. UTC time, we start seeing pressure build up. To the right of this is where the solar energy is coming from. Now you see a double band of energy, all happening from that 8 o'clock to the 10 o'clock time between when this left the solar surface and struck the planet. You're looking at a diagram of satellites circling the Earth, and that's where we're getting this information that's coming in. But as it goes through the afternoon, the energy is still increasing. That's what I'm saying. There was more than one burst. But the key thing is the coronal mass ejection. It will take up to 24 to 36 hours, maybe a little more sometimes. We're looking at CERN. During that time, you see different dips, but I'm going to go to the last 2 days of the scale. That green line is the beam energy line. It's running at 13 tera-electron volts, 6.5 per beam. Again, beam 2 is not showing on their screen, but beam 1 is fluctuating quite a bit at that power level. Again, it's not as intense as we saw it get before they shut it down last year, guys. This thing was really getting up there. But when you look at this time, and we're saying 8 o'clock this morning, up to about 12 o'clock with the green arrow, is when the activity was at its highest. Both beams were at 6.5 each, creating the 13 in intensity, and the energy was up. But Switzerland's time is 2 hours ahead of universal time. That means you've got to back this back 2 hours to match it to what the rest of the world uses as far as the scientists use. They use the Geneva time there. So you're going from here, where you see it rise about 9:30 back to about 7:30 until about 11:30, guys, or 12:30, and that matches the time that we saw the earthquakes. It matches the time we saw the release of the solar filament. But tomorrow, on April 11th at 11 a.m. Central, I'm going to be a guest again with Paul Begley at paulbegleyprophecy.com. I will put a link. Many of you know him. He's a friend to a lot of us. But, guys, that's 11 a.m. Central is when the show starts. I'll call in about 12, but join the show at 11.